Here's a short video to explain how to write formulas for ionic compounds. We'll start out with a couple of tips. When you write the formula for an ionic compound, the positive ions are always written first. Negative ions are written second, and the entire formula must add up to a charge of 0. The positive charge must equal the negative charge. To indicate the number of ions, we use subscripts written after the symbol or formula for each ion. A subscript of 1 is not written, it's understood. And whenever we have more than one polyatomic ion, we need to put parentheses around them to indicate how many groups we have. A couple of practice exercises. If I start out with sodium chloride, I have to recognize what each of these names tells me. This is the name for the compound, but it includes sodium ions, which are Na+, and chloride ions, which are Cl-. Now, I have to find what combination of sodium chloride adds up to a neutral formula. So let's start out with one of each. And if I bring one of each ion out, I see, well, +1 and -1. That right now adds up to a charge of 0. So in my formula, I need to show that there's 1 sodium and 1 chloride. My formula then is NaCl. Since there's 1 of each, I don't need any subscripts. For the next example, we'll look at magnesium bromide. I have magnesium ions, Mg2+. Bromide ions are Br1-. Again, my goal is to find what combination would have a charge of 0. So if I bring one of each together, you see that there's more positive charge than there is negative. So let's bring another negative ion out. Now if I add these up, this 2+ is balanced by the 2 1-. So that equals 0. In my formula, I need to show 1 magnesium and I need to show 2 bromides. So my formula is MgBr2. Let's try aluminum sulfide. Aluminum is Al3+, sulfide is S2-. Starting with 1 ion of each. Right now you see 3+ and 2-, there'd be more positive charge than negative. So I'll bring out another negative. Now if we add them up, +3 -4, there's more negative than positive. So I'll bring out a positive. +6 -4, there's more positive than negative. +6 -6, this now equals 0. In my formula, I need to show 2 aluminums and I need to show 3 sulfides. So my formula is Al2S3. One more example. Iron 3 nitrate. My iron 3 ion is Fe+3. My nitrate ion is NO3 1-. This is a polyatomic ion. Now, for purposes of making my formula, everything else still applies. Even though this is a polyatomic ion, I treat it like a single ion. If I bring one of each out, the charges don't add up to 0. I have more positive than negative. Bring a second one out, I still have more positive than negative. It takes 3 nitrates at -1 to balance the charge of just 1 iron 3. So now it equals 0. In my formula, I'll need to show just 1 iron and I'll need to show 3 nitrates. Now, how do we do this? Sometimes I have students that just write down FeNO3 3. But if you really look at this, that doesn't mean 3 nitrates. That means 33 oxygen and 1 nitrogen. So this is not what we're looking for. I'm just going to line that out. Here's another option. You might look at this formula and say, well, we had 1 iron, and if you count, there'd be 3 nitrogen, and if you count, there'd be 9 oxygen. And technically, this has the right number of atoms, but it doesn't show how they're grouped together. It doesn't show the nitrates. And so we can do better than this. So I'm going to line this one out. All right, the way we actually show it, and you remember from our tips, we said when there's more than 1 polyatomic ion, we're going to use parentheses. So in my formula, I have just my 1 iron, and I have 3 nitrates. So I put the nitrate in parentheses and put a 3 outside of the parentheses. That now means 3 of everything in the parentheses. That would be 3 nitrogen, and 3 times 3 is 9 oxygen. This is the correct way of writing the formula for iron 3 nitrate. Thanks for watching. I hope that got you started on writing formulas for ionic compounds. Good luck.